So the last data structure we're going to talk about in Python, for now at least, are called sets. So you already know what a set is. A set's just like a set for in mathematics. Okay, so they're mutable. They're a collection of items. They're like lists in that way. They're unordered though. So like dictionaries, they're unordered. Okay, since they're modeling sets in mathematics, there are no duplicates allowed, and there are going to be methods available to do unions, intersections, differences, all those things. Okay. So like dictionaries, they're declared with the curly braces, but without the colon separating the key value pairs. So here I have evens, which is a set of 2, 4, 6, 8, 10, 12. Okay. So a set can have any immutable object added to it. Okay. Immutable is the key. So I can add here, I've added a tuple, I've added a string, I've added a number. Those are all immutable. You can't add a list because lists are not immutable. They're mutable. Okay. So that would be an issue. Okay. You can also add an item to your set with the add function. Add whatever value you want. Again, could be anything. It could be anything that's immutable. It could be a string, could be a number, it could be a tuple. Okay. When it comes to discarding or removing a value, you have two options for deleting, I guess it's a more generic term. You have discard, you have remove. They look the same, and that you just say the name of your set dot discard or dot remove, and then the value you want to remove. The difference is discard, if it doesn't find the item, it just goes on its merry way. Okay. Where remove will throw an error if it doesn't find it. Okay. That's kind of what the difference is there. Okay. Pop is an interesting one. Pop used to be very convenient for making games of guess the state capitals, which usually you have to do in your Python class. Pop used to return a random item from the set, which is interesting, but it seems now to not do that. It seems like it's now doing the first item, which is weird because there's no order there. So I'm gonna have to do a little more research till I'm fully convinced what the pop is doing. The pop's going to remove something. I'm not 100% sure if we can guarantee what that's going to be. Okay. The main reason that we have the sets, of course, are to do the set operations. Okay. So set operations, I've got here, I'm creating a new set, and you can create a set from a list. So I'm using the set constructor function with range. Range returns a list. This gives me 1 to 10. Okay. So I can do a union. And the way you do that, you start with one of the two sets, dot union the other set. Okay, that's just gonna, and that returns a set. It's a subset, okay, of that. Same thing for intersection, for the difference, and for the symmetric difference. Okay, so if you run these, you get all of those things. Okay, and that should be how that works. Okay. I think, I didn't see this, so I didn't try. I think we can iterate. Let's see. So let's do for X in evens. Print X. See if that works. I suspect it will. It does, which is fine. Okay, and I should also be able to say if, say, 12, then I'll do 2 in evens. Print even, whatever. Hopefully that works as well. They're a sequence. Was 2 not in evens? It's weird. It didn't give me an error message, but it didn't print anything out either. Oh, weird. Apparently 2 was not an even. I must have done something to it somewhere along the way. Oh, when I popped it, that got rid of it too. Yeah, so in and not in work, and you can iterate with for loops. Okay, so it should be basically like you've done before. So again, the takeaway about sets, unique elements, and they have the set functions, union, intersect, all that built in. Okay. So that wasn't on the list for this week, but we've covered the rest of them, so figure we cover that one as well. If you have questions, make sure